our topic is the social interaction analysis. In our society, we have a lot of different kind of the social interactions, such as you have friendly relationship with your friends, you have a competitor in your market. Our target is to divide. For a new photo, we can classify it into this 8 dimension to get which relationship does this photo is.
Then we talk about some background information. We follow the psychological study of the 1982 interpersonal cycle, which describes the social interaction with 8 dimensions. Each dimension is either positive or negative for an image. You see the right-hand side of the poster. The left-hand side image is the positive image, and the right-hand side is the negative image. We divide them into 8 dimensions, which is shown in the photos. Then we talk about the data collection.
For the data collection, it is separate to 2 parts. One is the image, the other one is the video frames. For the images and the video frames, we also get it from the internet. They from some Oscar movies, YouTube talk shows, and some famous people's photos. Our target is to get the 6,000 images and the 20,000 video frames.
Then we do the face labeling. We use a tool for mark the faces, and the coordinates of the 2 boxes are automatically saved in a file. Then we use the image and the coordinates to run into a MATLAB program. The result shows that the 2 boxes are marked around the faces. After we doing this process, we then do the feature extraction.
For the feature extraction, we have 2 methods. One is the local binary patterns called LBP. For LBP, we found a central pixels to compare with the 8 pixels in the neighborhoods, in the 3 and times 3 neighborhoods. For example, in this example, 3 is larger than 2, we encode it as 1, 1 is smaller than 2, so we encode it as 0. Then we get the left-hand side the square, and then we connect the binary number from the top left-hand side corner clockwise. Then we got the binary number, then we change the binary number into a decimal number. This decimal number is used for the labeling for each pixels. And although this method is easy to compute, but it only suitable for the small size of the texture, so we use the circular LBP. Circular LBP is the same idea as the previous one, but it can serve for some pixels with the non-integers coordinate. Then for these pixels, we use the bilinear interpolation, then use the following 2 formula, then we get their coordinate and compare with the central pixel as the previous one. Larger we encode it as 1, smaller we encode as 0, then we got the binary number, then we change to the decimal number. This is the overview of the LBP. For images, we divide into some small blocks, then the small blocks and change to the LBP histogram, then combine all the histogram into a feature histogram. It's like getting the images feature factors.
Then we use another feature extraction, which is a histogram of oriented gradient. It counts the occurrence of gradient orientation in localized portions of an image. The first step we need to find is the gradient value. The simpler way is to consider 1D centered point discrete derivative mass in horizontal and vertical directions. And then we use these 2 masks to find the Ix and Iy, and use Ix and Iy to find the magnitude of the gradient. Then we need to create the cell diagrams. Each pixel calculates a weighted flow for an edge orientation histogram channel based on the orientation of the gradient element centered on it. The histogram is shown on the poster, and this histogram we will sum up all the histogram and then use it as a feature vector. Also, we need to normalize the gradient because of the contrast. The idea is that group the cell together into a larger spectrally connected box. Then the following formula is finding the normalization. Normalization can ensure the low contrast regions are straight. After we doing the feature extraction, we then do the classification.
For the classification, we use the support vector machine called SVM. SVM is a running machine. We have a set of the training data. Look at these photos. For the training data is separated into two categories. In these photos, such as the red points is the yes categories and the white point is the no categories. Then the SVM build a model for predicting the new example belongs to which categories. Our idea is to make the distance between the yes or no categories as larger as possible because it can make our final result more clear.
In our project, we use 5,000 images and video feeds to do the training model for each dimension. And the ratio of the positive interaction and negative interactions is about 8:2. Then we use about 500 images for the testing the model. Here is our result. The accuracy is about 50 to 60%, which is acceptable. However, we find that we can improve the accuracy. So in the next semester, we will make the improvement, such as we use another feature extraction or combine LBP and Hawk to do the feature extractions. Also, we will decrease the dimension of the feature vector so that we can get a more accurate result. That's the end of our presentation.